Hello, it's July 8th, 2014. I'm doing a MathBabbler bit. A few days ago, the Mathematical Association of America posted to their Twitter account, which has the handle MAA now, a number of the day, and the number of the day was the number 8,811. When I saw that that was the number of the day, I immediately asked why. And so I clicked on the hyperlink that was in the tweet and looked at the web page that they had created for this particular number. And one of the things that was pointed out was that 8,811 is a multiple of 11, and the number in its digital representation contains an 11. So that made me think of a potential programming assignment. Get an integer as input, and then go through all of the proper divisors for that integer to see if those proper divisors are contained in the digital representation of the number. So we wrote a program, and the first number that we used with our new program was the number 2,448. My @NanoFoo Twitter account had a Twitter milestone the other day. It hit 6,300 tweets. And it took 2,448 days to tweet the 6,300 tweets. So I typed the 2,448 into this program that we wrote, and it turns out the output from the program told me that the proper divisor 2 is contained in the number. The proper divisor 4 is contained in the number. 8 evenly divides into 2,448. It's contained in the digital representation of the number, as is the number 24. 24 is a proper divisor of 2,448, and 24 is contained in the digital representation of the number. The second time we ran this program was for the number 17,068, and I think that was done after the stock market closed on July 3rd. On July 3rd of this year, 17,068 was the close of the Dow Jones Industrial Average, and it was the first time in the history of the Dow that it closed above 17,000. So I typed 17,068 into this program, and it printed three outputs. 17,068 is a multiple of 1, and 1 is contained in its digital representation. 17 is a proper divisor of 17,068, and in its digital representation it contains a 17. And then 68 is a proper divisor of 17,068, and sure enough, 68 is contained in the digital representation of 17,068. With respect to this, the online Encyclopedia of Integer Sequences, OEIS.org, has sequences defined for all of the numbers 1 through 20 that basically, so there's an integer sequence that this number is contained in for 11 and 1. There are integer sequences for 2, 4, 8, and an integer sequence for 17. There is not an integer sequence defined for the multiples of 24, nor is there an integer sequence defined for the multiples of 68. Why there's not, I don't know. So anyway, this is going to become a programming assignment. If I can write the program, then students should be able to write it too. So I think that's all I have to say for this MathBabbler bit and movie.